Dear students, now I am going to discuss a question from the topic called digital communication, which is very important as far as GATE, ECE or any public sector undertakings are concerned. And I selected this question from our NPTEL workbook, and you can find this question in our workbook from the page number 227 and the question number is 91. Yes. So this is a very good question, and you can find a lot of these questions in our workbook. Please refer our workbook. And what is this question? Let us understand and try to solve the question. So here I'll try to read the question first. A message 3 sin 2 pi t into 10 power 3 is transmitted through a channel using a digital communication system. Okay. Sampling rate of the signal is 100% higher than the Nyquist rate and is quantized using a 256 level quantizer. Okay. So the first question is related to pulse code modulation, PCM. What is the bandwidth of the resultant baseband waveform when roll-off factor is 0.5? He gave the options. Now the second question is, what is the bandwidth if passband 16 PAM and a roll-off factor of 1 is used? These kind of questions are very, very important. Now let us write the given data first. So what is the message signal he gave? M of t, if I denote 3 sin 2 pi into 10 power 3t. This is a message signal, right? Now here, whenever you are given a message signal, what is the highest frequency component? Here 1 kilohertz. What is the highest frequency component? 1 kilohertz. So what is the Nyquist rate? Nyquist rate is twice the highest frequency component, 2 kilohertz. Nyquist rate is 2 kilohertz, right? So readily we can find out this, and is transmitted through a channel using digital communication system. Sampling rate is how much? Sampling rate is 100% higher than the Nyquist rate. 100% higher than the Nyquist rate means Nyquist rate plus 100% of Nyquist rate. So Nyquist rate plus Nyquist rate, 2 times of Nyquist rate. Suppose instead if he says 50, if the sampling rate is 50% higher than the Nyquist rate means 1.5 times of Nyquist rate. Suppose if he says that sampling rate is 75% higher than the Nyquist rate means 1.75 times of Nyquist rate. So 100% he said no, so 2 times of NR. Okay, fine. Now what will happen? Nyquist rate means this is 2 times of 2 kilohertz, which is nothing but 4 kilohertz. 4 kilohertz or 4000 samples per second is the sampling rate. Now after this, what information he gave? Yeah, and it is first it is sampled and quantized. So how many level quantizer he took? 256 level quantizer he took. And we know that the number of bits and the number of quantization levels are related like this. L is equal to 2 power n. Now equating, what will happen? 2 power n is equal to 256, which can be given as 2 power 8. So how many bits we are going to use? N bits, right? So n bits means, can I say that the system what he is using is a n-bit PCM, 8-bit PCM system? Yes. If he is using n bits means n-bit PCM system. Now 8 bits he is using means 8-bit PCM system he is using, right? Means each sample value is encoded into how many bits? 8 bits. 8 bits, right? What is the bandwidth of the resulting baseband waveform if the roll-off factor is 0.5? Bandwidth he is asking. See, bandwidth means he may use rectangular pulses or he may use raised cosine pulses. If he uses rectangular pulses, so if he uses rectangular pulses, bandwidth means maximum bandwidth only will calculate. Maximum bandwidth is RB hertz. Simply RB hertz. Now instead of this rectangular pulses, he may use raised cosine pulses. What is the purpose of using raised cosine pulses? Because if you are going to use rectangular pulses, there may be a possibility of inter-symbol interference. Inter-symbol interference with which the probability of error increases. So in order to decrease the probability of error, so they can use raised cosine pulses. So roll-off factor is 0.5 means yes, he is using a raised cosine pulse. Now whenever you are going to use a raised cosine pulse, what is the bandwidth? What is the bandwidth? See, whenever they say roll-off factor means when in your bandwidth expression, wherever you have RB, replace with RB by 2 into 1 plus alpha. Whenever they say this roll-off factor means in your bandwidth expression, replace this RB with RB by 2 into 1 plus alpha. So what will happen to the bandwidth? RB by 2 into 1 plus alpha. This is the expression we have to use. Right? Now RB means 1 plus alpha means 1.5. No? So let me go to the next slide. Bandwidth is equal to RB by 2 into 1 plus alpha. Our bandwidth is equal to RB means, can I write NFS? Yes, by 2 into 1 plus alpha means 1.5. Right? Our bandwidth is equal to N means 8, number of bits are 8, Fs means 4000, 4 kilohertz, 4000 by 2 into 15 by 10. Alright, now how you are going to simplify this one? So this will go 0, 0 cancel, and this will go for how many times? 200, isn't it? So this is 1600 multiplied with 15, which is nothing but 24 kilohertz you will get. What is that you are going to get? 24 kilohertz. So yes, we are having 24 kilohertz in the option B. Option B will become your answer. N Fs by 2 into 1 plus alpha. Right? 24 kilohertz. Now extension to this question, he said, what is the bandwidth if passband 16 PAM and a roll-off factor of 1 is used? See, first of all, what is the purpose of PAM systems? Generally, we say PAM as M level PAM. M level PAM, in which we'll get the concept of symbols. We'll get the concept of symbols. The idea is, suppose if I am going to transmit a rectangular pulse of width TB. Now, what is the bandwidth I can get here? Bandwidth is nothing but RB hertz. RB hertz. Now, if I can increase the width of this rectangular pulse from TB to 2 TB, TB to 2 TB. So what happens to the bandwidth? It becomes RB by 2 hertz, right? So this is a bit, this is a symbol. Grouping of bits becomes a symbol. Grouping of bits becomes a symbol. Here, whenever we are transmitting bits, we'll talk about bit rate. Whenever you are talking about symbols, we'll talk about symbol rate. So in M level PM, we'll talk about symbol rate, right? Now, here, see how we got this bandwidth. Basically, we are rectangular pulse means rectangular pulse of width TB. If I am going to take, its Fourier transform can be given like this. Fourier transform can be given, and here we'll neglect all the side lobes and we'll consider only the main lobe and the first null. This is nothing but the first null, which is nothing but the reciprocal of this width 1 by TB, which is nothing but RB. Suppose if I take a rectangular pulse of width 2 TB, what will happen? Here also the Fourier transform will be a sync pulse kind of thing, but here 1 by 2 TB, this is the first null. So we are going to calculate the bandwidth. Practical bandwidth is calculated up to for practical bandwidth we are going to consider only the main lobe, and here this will be reciprocal of the pulse width. 1 by 2 TB is nothing but RB by 2. RB by 2. So here in M level PM we'll be grouping the bits to form symbols, right? That is so that the bandwidth decreases, because in the transmission always we must remember one point, that signal bandwidth must be as small as possible, and channel bandwidth must be as high as possible. So if you are going for M level PM, the bandwidth can be given as the maximum bandwidth RB by log m to the base 2. RB by log m to the base 2 if rectangular pulses are used. If rectangular pulses are used. What happens if raised cosine pulses are used? I told you, raised cosine pulses means where in the maximum bandwidth, wherever you have RB, replace that with RB by 2 into 1 plus alpha, right? So what happens to the bandwidth now? RB by 2 to 1 plus alpha to log m to the base 2. Log m to the base 2, or this is NFS into 1 plus alpha by 2 log m to the base 2. Our bandwidth is equal to, n means 8, Fs means 4000 into 1.5 by 2 log m to the base 2. Log m is nothing but the number of symbols. M is nothing but the number of symbols, and 16 pm. So 16 pm he said, no. So 16 pm is m is 16. So log 16 to the base 2 will be 4, right? So this will be, I can remove this and I can put 4 here. I can put 4. Now what will happen? So this is 4,000 times this will go 1,000 times, and this will go 4 times. So 4,000 15 by 10 0 0, or this is 6 kilohertz, isn't it? 6 kilohertz. So bandwidth is 6 kilohertz. Let us verify whether we are going to have 6 kilohertz. So we are not having this option in the, we are not having this 6 kilohertz, but 6 kilohertz will be your answer. 6 kilohertz. Now you can see, you can observe the bandwidth got reduced from, see, whenever you are going to use your PCM, what is the bandwidth we got? 24 kilohertz. Suppose for the same thing, if you are going to use M level PM, and if you are going to make grouping bits and making symbols, bandwidth got reduced. So that is the advantage. Anyway, this 6 kilohertz is not there in the options, but this is only the answer. Okay. Now, hope you understood this problem, and lot of these kind of, many these kind of questions are available in our NPTEL workbook. Please refer our workbook. Thank you.